Hi everybody, this is Dark Guardsman, and we're back with another video. Now this is going to be a dev work video, so it's going to be an update or isn't going to be something, but it's actually going to be closer to kind of a quick talk, because I got to wait for Minecraft to load to go back to doing what I'm doing. And what I want to do is kind of talk about code structure. I've been helping Cell48 work on a mod he's working on, and I realized he and probably others don't really understand that there's a structure, a preferred structure. It's not really required, and you don't have to follow it. But it does make life massively easier when you're working on a mod. So let's go ahead and close all this down. It doesn't even have to be a mod, it could be any type of software. So ignoring my massive workspace, let's go ahead and make a new project here. So new modular. And you can actually do new project, new modular, whatever, it doesn't matter. So we're just going to call this, let's call it Room Manager. And this is very similar to what he's working on. He's working on what basically a flight manager allows you to effectively check into a flight, track how many seats are used and how much baggage is used. At least that's what the impression I got from what he's working on. A little hard to tell from his code because it's not documented very well, but it's okay. He's new to this. I don't expect to see amazing documentation as somebody who's just started into coding and hasn't exactly had to deal with a lot of other developers. But we'll get Room Manager here, and yeah, we'll just leave the content root in voltage, and I'll delete this later. So this should show up eventually inside the list over here. And it's a thinking. Right there it is. So we're going to get an empty modular here, and what we just want to do is make a new package. Now, to start with, one of the first things you do when you structure a mod is you need to probably get some kind of package going up. If you're just making a really simple, or actually, I use the word mod, when you're working on your application, you need to get some kind of package going up. This is the same for mods as well, so this advice goes back and forth. But you want a package going up. If it's really, really simple, like you're working on just a really quick application to say do like 2 + 2, you don't have to. You could just make a main method and do your whatever your work you want to do. There's a lot of times when I'm doing homework for class and I need to calculate a really hard problem, I will just make a main method and I'll just start typing into it. But you want to package things. So the recommended way to do this, and this is not a standard, although it's kind of become a standard without being officially declared, you want to start off by using your website if you have one. So whatever site you plan to release a software, it should be what it is. So we do Build Broken because that's what our organization is. And I believe it's just one word is what I end up using half the time. So Build Broken, and then the name of the project, this will be Room, is what we'll call it. It doesn't have to be perfect, you just need something that's easily identifiable and easily distinguishable from a lot of other packages. Keep in mind the whole reason this is ever done is say you merged a whole bunch of jars together to run. If you had some overlap, it gets confusing, and you could have actual problems. So you want to make sure you have some kind of unique system going on here, and it could be as simple as your name. Like in Cell48's case, he could literally just put his name at the front of the package, and it would be perfectly fine. That could be his package name. So we get that, and the next thing you want to do, a main method. So you got your main method up. Now, hopefully before you went and started making your own application, you had some kind of design. Now, Cell doesn't really have a design, he's a concept. So what he has is like what he wants to make, but I doubt he's gone through the detail level what you do. So I made this for him real quick to kind of explain kind of what do you want to do. So if you're making a data entry application, which is basically what he's doing. You got your main method, you want to load your data up, you want to init your logic class, you want to init your interface, and then you want to run your loop. The order of this doesn't really matter heavily. Preferably you want your logic before your interface because the logic is going to tie directly to the interface, and you can leave your data for last if you want to. But what this is most people might recognize this as a 3-layer application. It's the concept that you break your data away from your logic and away from your presentation layer. Presentation is any graphics, any kind of user interface, anything that talks between the user and your logic and data. And then your logic is supposed to talk to your data. How this is basically works, the reason why I flowed this out is because your interface talks to your logic and your logic talks to your data. Your interface should never really have access to the data directly. It should always access the data through the logic. And it kind of helps clean up everything. And the reason I'm showing this off is because it's probably one of the best ways to structure your application or even mod in order to kind of keep it nice and clean. When you're working with mods, you actually end up doing a lot more work. Like you start breaking your data into like raw data and then content. because then you have your content, which your content is going to be a little fugly because your content is going to be not only data, but it's going to be logic and presentation, so it's actually going to be all three, so it's sometimes good to put that in a separate little category by itself. And then you'd have your presentation, which would be your GUIs, and you'd have your logic, which would be like event handlers and stuff. I'll get into that another day when we're talking about mods specifically. So we got a main class. We're going to, of course, have public static void main string args. Now when it comes to main method, by the way, you can end up doing this like two different ways. You can do this way, which I like to do, which is the 3 dots, or you can do it this way. It doesn't matter. Java will recognize both. You can put a little document saying this is your main method, and of course you want to make sure you put your author at the top so people know who made it, and you can put a license up here if you're like me and have it auto injected at the top. So when structuring the mod, or I mean structuring the app, I'm going to get those two confused back and forth because my brain is so accustomed to mods these days. So we want to structure this. So we're going to have exactly how that diagram was showing. So public void load data. So we're going to have some kind of data loaded. This is going to be basically our room. This is what we're going to load in here. Now we're not going to make an actual class for this. You could make a class. Now it depends on how much you're going to actually be doing. I'm going to do a lot more in the main class because this might help Cell48 here understand kind of the direction I'm leaning towards. I'm not telling him simply when I say, hey, go do a logic system or something, you have to make a class. You actually could do everything in the main method still, or main class, and just simply break it down. Break it down into something that's manageable. That's the whole idea about structuring your mod and doing some patterns and stuff. It's all about making your life easier. So we'll end up having 3 methods, and we're going to have a init logic. So we're going to have some setup phase to make our logic work, and we have some setup phase to make our GUIs work. And to be honest, this is probably not going to look exactly beautiful. And what's going to end up happening is we're probably going to turn one of these into a run method. And the final thing is we're going to have a loop. So we're going to have a public static void, and we're going to call this run loop. Minecraft actually has something identical to this. It actually has something called a run loop in it too. But you do this. So you load data, init your logic. The reason why we don't call it load logic is because you're not really loading anything, you're actually initializing. And the data, that technically is what we're doing too, but theoretically what you could come down here later is put like a file reader in here and actually read a file from local. In our case, we're just going to put some basic data in here. For our basic data, we're just going to use a map. So we're going to do public static, and by the way, everything in here has to be static unless we make an object system for it. So we'll have public static, and we're going to use a hash map. It doesn't have to be a hash map, but it's easier this way. And we're going to use room numbers to names, because I don't actually want to make an object for this, because this is just about the structure, so we're not going to do a whole bunch of object creation. And these will be our rooms. And we're going to leave that as not initialized, and in load data, we're going to go, okay, rooms equals new hash map, and you can do the diamond thing, and you could actually do like up here and put this here. It's actually not required anymore. If you do, I think Java 7 allows you to completely ignore it, and 8 allows you to completely get rid of it. There's actually some kind of thing for it. But for our rooms, say we just want to make some test data. Say we're just really early into development, and we haven't got to the point where we know 100% what we're doing. We just want to go like this. Okay, we have room 0 as named Funky Room. And we make, like, say, 4 rooms. 1, 2, 3. And let's say this is the party room. Make this the jazz room. And this will just be the norm room. Gotta have a normal room. Makes all the other rooms cool if you have one that's just normal. So we got all our data, so that loads up our data. Cool, we got the first one up. Now our logic's going to be a little bit more tricky because, well, it's a little hard to initialize anything if you got nothing to really initialize. So this would be where an actual class would be probably used, and we'll just make something really simple here. So we'll make just a little thing called logic, and we'll just initialize it. So we'll make a method up here. So public static logic, and we'll make our logic. You could have, if you were making an actual application, you could end up having a ton of different logic bits in here. You can have a little bit of everything if you want in here. So this could be, like if you were working on like a database manager, this could be where you start loading your database application. This is where you start loading up, well actually your database would be loaded up here. So you load up your database plugin up here, actually access the database and pull all your data in. Theoretically, you wouldn't actually load all your data in when you start the thing, is you would load only important stuff. But in your logic, you could load your database handler, your actual interface handlers and stuff like that. Whatever it could be considered logic. The difference is with a 3-layer design, is your data is basically all your data. So all the raw data, all the storage of the data. Your logic is everything that you use to manipulate the data, how you like work with the data. Like if you have 2 data points and you want to compare the two, that would be logic. If you have a method that would take this data point and turn it into a new data point, that would be your logic. What is considered just data is just the data. How you access the data, how you save and store it, and that's nothing else. And then your interface is just how you display the data. How does the user click a function and have logic do something? That would be your interface. Our interface, we're not really going to have much of anything. We'll make another object for this, and at this point I almost kind of want to make a data. Yeah, let's just make a data object too. So we're going to make we'll make a data handler. And in our data handler, we're going to do this. And we're going to make this not static. And we'll just go full weight. I didn't really want to do objects, but again, this is not scripted. And I'm definitely going to have to make another video on this later. So this would be our data. And in here, we're going to have to take this guy, and what we're going to do is do public data handler. And we're just going to use a constructor for this. You wouldn't actually end up using a constructor, and you wouldn't really avoid using a constructor for anything more than, say, doing like that. So actually, to keep this example pretty good, we'll do a method. So public void and init, or it could be load. So it'd be like, hey, load data. And we'll put that here. So we have our data handler, and we'll make our data handler, so equals new data handler. And you could have like tons of stuff in here. Like your load data, you could be like, say I was making a really cool business application, I could have like my sales report manager, I could have my store manager. So there'd be like a manager that went, or a little data manager that went to every store and asked them for data. You'd have another manager that went and grabbed all the sales information from accounting. You'd have another data manager that maybe went to go all the warehouses and grabbed all the information. You could have tons and tons of data handlers loaded up at your data phase. And then in your logic, you could have all your logic handlers that interact with all this data. So like, hey, this is the sales report compiler, this is the warehouse management logic system, and so on and so on. So for this, we're actually going to want to pass in some data. So when you actually make your data logic, one of the ways you can do it is actually passing in arguments. There's 1,000 ways to actually end up doing this, and we're just going to show one way, and don't take this as the guaranteed way to do things. Kind of experiment on your own and figure out what you prefer and what is usually recommended for whatever you're doing. In this case, we're going to store the data handler this way. We don't actually have to access the data handler every single time we want it. It's already in our class file. And we could have something like public, we'll make a method here, and we'll make one called find rooms. String, actually, maybe not find rooms, we'll get empty rooms. And we'll have to create some kind of way to track that in a second, and we'll get to that. And we're just going to return null for the moment. So that would be our first piece of logic, and this will probably be where we end it too. It's just a find room method. So it'll be like, hey, get empty rooms, and we'll do some logic for that. And in here, we'll pass in our data. And then we'll have our last object, which will be interface. And there would be a way to also, if you ever did this, you'd be packaging these as well. So if you could do like GUI right here, and this would be your interface. Actually, I don't think I could use interface. So we'll actually call this user interaction. Because if I do interface, it's going to actually error out probably. And in our user interface, we'd have logic. So logic would be our actual system we access. And so how we get all of our information. Interface and logic. So that'll get that going. And then we're going to need an update method here because we're going to be running this like every so often. Or actually, we'll call this run, because update is a little weird, because if we call it update, we're presuming it's going to be running every tick, but that's the reality what's not going to actually work. What's actually going to happen down here is when we get our interface up here. So we'll do public, static, and you wouldn't even have to, if you actually made this a certain way, be putting all these up at the top. The reason why I'm doing it is just to make it the example work out. And there is, once again, a ton of different ways to do this. And this would be our logic passed in. So you could actually, in your constructor, or in your main up here, get rid of all the methods and just call each one of these. And that would be what you're doing. But just to keep it simple, you got data, logic, and interface. In our run loop, we're going to call, and we're going to do this, we're going to go while should be running. Now this is actually going to be, actually, we'll make it this way. So I know a way to do this where we don't have it be like really complicated. So we'll do run, and then we'll do run equals user interface dot run, and then we'll come over to our run method, and we're going to make a return a boolean. And what this would be is at the very end, we're going to ask the user, hey, do you want to keep running the application? And there we go. That should like create a while loop, and right at the bottom we'll exit, and we can do some really simple things here, like we do some print line, so system.out.println. It'd be like start, just so we can keep track of each thing. And then we'll be like stop. And then each one of these can be like, hey, we created data, loaded data, loaded logic, and then this would be loaded interface. And we can check to make sure all this runs really quick. So we can just right click if you're in IntelliJ and hit run main, and we should see a console pop up and go, hey, we actually did stuff. And it'd be like, yeah, start, loaded data, loaded logic, loaded interface, and then stopped. Which is weird because it should have written in the run loop and actually did something. So while run, I think we actually did return false, didn't we? Yeah, we returned false. So what, in reality, what we'd want to do is return true here, and we would then make another print line going, okay, running interface, and this would just go on forever, is what this would actually do. So if we hit actual run again, so if I hit run main, ignoring the fact Minecraft, if it would loop, we would have to kill it because it would never stop. So when it comes to the actual logic and everything getting run, so we know we have rooms. Now we want to do some kind of system. So this is where you would actually end up breaking your data out to an actual thing, and you make another package called data. Move your data handler up there, and in here we would have an object called room. And our object would have public string name, and then public boolean is taken. And we would just leave those pretty much as is. Actually, we'll do this way. We'll make a constructor. So constructor basically is just a method for those who don't really understand what they are. And they should pretty much be used for only assigning data. In Cell's case, he actually put some logic up in there, which is not his fault. I actually used to do the same thing when I was novice to this. But you would do this, and you would just do is taken equals is taken. So we got a simple object here, and then what we can do up here is to change this to room. And then we can do new room. And since we're making our application only show rooms that are taken, we're going to say almost all of these are not taken. And then what we'll do is we'll change one to taken. So we'll go, okay, these are not taken. We'll say the jazz room's taken. Say some famous jazz musician came down and he wants to kind of party out while he's practicing his music. So we got all this set up, and we got our data. And what we forgot to do is actually, when we get into here, we forgot to load data. So data.load data. So that'll call that. So that creates our data object, then loads it, which then will pass into logic. And in our logic, we simply, and let's make a package for it so it doesn't feel left out. A simple package called logic. There we go. Nice clean structure. And we want to get our empty rooms. So this will be pretty simple. We go for, and we don't even have to really go with the IDs. So we can simply go and get the actual rooms themselves. So we can be room, and data handler dot rooms, and we want to get the values. So I'll just loop over all the rooms, and we then want to just make a list up here. So list rooms equals new array list. And import everything if it lets us. Oop, wrong button there. And then we go like if room dot is taken. Then we want to do, actually want to do not taken. Then we just do rooms dot add room. Now there's another way you actually could do this as well. Like if you want to be kind of like a hipster, kind of modern. I use the word hipster wrong because it used to be a hipster way to do it by using lambdas, and using streaming is actually what it's called. But now it's actually become a pretty good standard. So what you could do is you could actually stream, and you could do filter. And you could be like, hey, if r, and then you go r dot is taken. And you could be like, hey, collect and to stream, and you could actually return that. That would actually be your method here. We're going to do it the old school way because I like the old school way. This is cool. This is really simple, but it makes it a little hard to read. This way it's a little easier to read because what you can do is then you can come down into your comments here. And why is this actually complaining? Ah, because it wants a string. Maybe like, hey, I'm get all rooms. Because the really cool thing about actually not using the streams is you can actually document this. You can be like, hey, room is not taken, and you can be like add. You don't have to go to this in detail, and especially with a simple loop like this, it's pretty understandable what you're doing. You're collecting objects from a list, and you're going to return and get empty rooms. So we're going to do, and we're going to make our user interface. So finally our user interface, and we're just going to use JOption Paint for this. And actually, what's the best way to do this? So we're gonna do J option pane dot, and we want to show not an input dialog. Kind of want like an option dialog, like a yes no. It's been a while since I've actually used these. I think it is an option dialog. Array of options are possible choices. And then what it should do is an integer indicating the option chosen by the user. So this should work if we can remember how to actually type everything in. So we don't have a parent component. We do have a message. So our message is check for empty, or get empty rooms is what we're going to call this. Get empty rooms. And there should be a header. Empty room check. And it's going to want a set of options. So title, option type. So our option type is going to be somewhere stored in here. So it's going to be like J option pane something. J option pane. Actually, it should actually tell us. No. And this is not going to be. It's actually going to be yes no. It's going to be yes no cancel option. And we'll do cancel to exit. And we'll put like a dot there, and then it's going to actually want a little bit more data. So it's going to want a message type. It's actually going to want a lot of stuff, and I think there's actually a better way to do this. I think what we can do is use a show confirm, and this would actually give us a different type, show confirm. And that will let us actually get away without putting all the data in there. There we go. So this should show us an option here. So if we actually hit run, and we hit run again, we should get an option, and whenever we click, it's just going to loop back through and ask us the same thing over and over again. So no matter what we click, it's going to give us the same thing, and no Xing is going to get us anywhere. So what we want to do is, of course, if we end up hitting cancel, so we want an option back, so it's going to be like int option. So option 2 should be our cancel. So we'll do if option equals 2. Let's go ahead and test this because we're just running off a theory at the moment. Good idea to test your theories. And if we cancel, no. So let's actually, there's a trick to this. If you don't know what exactly is going to work, how it's going to work, run in debug mode. So option is 2. Option is not 2, is what we want. So if the option is 2, we want to actually do that. And we can reload this, and the next time around it should actually work. If it's going to take a while to reload because I got Minecraft running in the background. It's a longer video than I thought it was actually going to end up being. And I definitely am going to have to make a better video of this because we didn't really cover structure exactly appropriately. Hit play. And what should happen if I remove that is we hit cancel. Ignoring that GUI, that's the wrong one. Where did our GUI magic go off to? Aha, there it is. And kill everything here. Something apparently did not happen. Try this again. There we go. Okay, cancel worked. Okay, so now cancel button works. So now we want to actually do our stuff. So if option equals 1, or no, actually equals 0. So 0 should be yes. We want to show our empty rooms. So now we want to make another panel. First, we want to get our empty rooms. This will be list rooms equals logic dot get empty rooms. And then we can just make a J option pane that pops up and goes, hey, here's your empty rooms. And we're just going to be... So this will be empty room checks. So we're going to leave the empty room check title here. And we want this to just change to an OK button because we don't actually want anything from this. We just kind of want the option panel to go, yep, yeah, you've got empty rooms. And then now we want to make a string for this. So we're going to actually want to make a string to display this. And this will be, we're just going to call display. We're going to do that, and we're going to go 4. Yeah, we'll do 4 rooms here. Rooms. And we're going to go display plus equals room dot name, and then we're going to do a break line. I think the actual next line character will work in this, and we're just going to put this like right here. And actually, we want to make this empty rooms, and then of course have another next line there. So hopefully this will actually do exactly what I think it will. If it doesn't, well, we get close enough. And then we also, well, we can't do the alternative. Like if you actually were also going to do this and you did something like is empty, so you want to make sure like if you have no rooms, you actually have a custom display rather than an empty list. Of course, you could be just lazy and be like, hey, we don't actually care, and you could just be display nothing. But then the user would be like, hey, did it break? Be like, no empty rooms exist. And we can test this here in a second. So run debug again. I almost always just launch stuff in debug at this point. So you get up to your room, it's going to go yes, and go like, hey, we have the funk room, the party room, the norm room, and it'll give you a yes, no, and of course we didn't actually want a yes, no, so we're going to hit cancel. So OK option was supposed to give us returns value of the class if the closed window is selected. OK option. I think we selected the wrong type. So it's OK cancel option, and what we want is like the default option, I think is what we want. So let's do this. That's probably me not using J-option panes enough. I'm used to making my own GUIs at this point. And you'll find that out if you ever get into GUIs a lot. You'll end up using your own GUIs for this, because the J-option panes are basically a very primitive GUI type that is kind of given to you to act as a pop-up window for your actual application and do really simple things like what we're doing. But yeah, here we go. So we empty rooms and we go, yeah, funky room, party room, normal room, we're good. And it'll take us back, and we hit cancel, we can close. And then of course, if you didn't really like how that formatting looked and you want to do some indenting, you could sit here and have all kinds of fun. So we can do like a /T and it should format to the right. So if we launch that up. And if you're one of those people like watching this like, oh yeah, you could do a lot better formatting. Yeah, you could do a lot better formatting for this. Yeah, it looks like T doesn't actually work. So hit cancel. So what T is supposed to be your tab character. So we'll do that, and we'll launch one more time and see if that actually works. But yeah, that's pretty much your system though. So here we go, format's over, and we could do all kinds of stuff with this. Like there's ways to make this even nicer looking. And of course cancel. And we're gonna do the one last thing, which is show you what would happen if these are all set to taken. And of course, what we could also do is we could make an option menu at the very beginning and be like, hey, do you want to check empty rooms? Do you want to actually select a room? Like you could select a room and then type in the room name or do a drop-down menu. But that's a thing for another day. That would be something like if we did a full entire tutorial on how to make a GUI from start to finish and do data entry for it. So you get empty rooms, yep. And no empty rooms exist because they're all taken. And that's pretty much the end of this tutorial. The main thing I wanted to show with this was just kind of how to do your data setup. You want to basically break your application down into data, logic, interfaces, and then of course you have your run loop. So, but these are the three main parts. So you want to separate them, and the reason for separating it, it just makes your code really, really clean. But I'll explain this more in detail later because my dog apparently wants to either get walked or fed or something.